Hello, welcome back to my YouTube channel. In this video, I'm going to discuss how a charged particle gets deflected in an electric field. So, we know that a charged particle gets deflected in an electric field, and this deflection depends upon the strength of the electric field, the magnitude of the charge, and the mass of the charge. So, this was studied by J.J. Thomson. So, here we have got a positive charge, and this is the electric field region. So we can see that this is a positive plate and this is a negative plate, and the electric field is from positive plate to the negative plate. This arrow represents the electric field lines. So if I project this charge in this electric field, the charge will get deflected. So you can see that as it is projected, it is getting deflected. Now what will happen if I increase the strength of the electric field? So deflection is directly proportional to the strength of the electric field. That means if I increase the strength of the electric field, the deflection should be more. So I am increase the strength of the electric field, for example, to 1200 or 1500. Let us see. So when the electric field strength is 1500, the deflection is even more. If the electric field strength, for example, it is 2000, what will happen? Let's see. So you can see that as the electric field strength is increased, the deflection is even more. So let us see what happens if the electric field strength is 100. So if the electric field strength is just 100, we can see that the deflection is very less. We can hardly see any deflection. If the electric field strength is 500 Newton per Coulomb, we can see that the deflection seems little prominent. The particle is getting deflected. Now on further increase in the electric field strength, that is 1000 Newton per Coulomb, the deflection will be even more. You can see the deflection is even more. Now if I increase this electric field to 2000 Newton per Coulomb, what happens? You can see that the electric field strength is very high, the deflection is also very high. Therefore, the deflection is directly proportional to the strength of the electric field. More the electric field strength, more will be the deflection. Now let us see how the deflection of the charge is affected by the magnitude of the charge. So the deflection is directly proportional to the magnitude of the charge. So we can see that initially the magnitude of the charge is 1.2 microcoulomb. So the deflection of the particle is this. Now if I increase the magnitude of this charge to, for example, 5 microcoulomb, the magnitude of the charge is increased to 5 microcoulomb, so the deflection must increase since deflection is proportional to magnitude of charge. So you can see that as the magnitude of the charge is increased, the deflection is increased. If the magnitude of the charge is 1 microcoulomb, the deflection will be very less. You can see the deflection is very less. And if the magnitude of the charge is 5 microcoulomb, the deflection is very large. So it has been established that the deflection is directly proportional to the magnitude of the charge. Now at last, let us see how the deflection is affected by the mass of the charge. So you can see that deflection is inversely proportional to the mass of the charge. That means less the mass, more the deflection, and vice versa. So initially, if the mass of the particle is 0.2 into 10 to the power minus 16 kg, let us see how much deflection happens. Since the mass is very less, the deflection is very high. You can see the mass is only 0.2 into 10 to the power minus 16 kg. The deflection is very large. Now if I increase the mass from 0.2 into 10 to the power minus 16 kg to, for example, 2 2 into 10 to the power minus 16 kg. So if I increase the mass, the deflection should reduce. So you can see that as the mass is increased, the deflection is little less. Now on further increase the mass, for example 5 into 10 to the power minus 16 kg, the deflection should be even less now. So you can see as the mass is further increased, the deflection is very less. So less the mass, more the deflection, more the mass, less the deflection. So in this animation, we have verified the experiment of J.J. Thomson that the deflection of a charged particle in an electric field is directly proportional to the strength of the electric field, directly proportional to the magnitude of the charge, and inversely proportional to the mass of the charge. So if we see a term called charge to mass ratio, so deflection is directly proportional to charge to mass ratio. If the charge to mass ratio is less, the deflection will be less. If the charge to mass ratio is more, the deflection is more. I hope you have understood. Thank you.